This is a Series A investor presentation about the BESS project, that stands for Brazilian Energy Cane Self-Sustainable Technologies for SAF Production. This proposal outlines a conceptual project carried out by Cenerbio using energy cane to produce sustainable aviation fuel with low carbon intensity and high energy output. It's a disruptive concept of integrating biological first-generation ethanol and thermocatalytic technologies for production of SAF, ethanol, and bioenergy from energy cane non-food crop. After this presentation, the investors shall get the main takeaways. Energy cane is the best available in commercial energy crop with the highest biofuels per area yield. Brazil has a unique position in the world to supply SAF produced from low carbon intensity feedstocks. Forecasted potential of SAF production in the world and in Central South America region, and the impact of the BESS SAF project. Preliminary economics data of BESS SAF project. The main purpose of this presentation is to discuss with investors a possible partnership for investing in a front-end engineering design study to deliver a basic engineering project pre-final investment decision for production of ethanol and SAF in Brazil. Energy cane. Energy cane is a designation of a specific group of sugarcane varieties optimized for biofuels and bioenergy production. Energy cane is a non-food, non-transgenic energy crop supported by a specific and robust genetic improvement breeding program that offers unique competitive advantages over other biomass sources. Energy cane has a sophisticated biochemical pathways, C4-type photosynthetic metabolism, involving the incorporation of carbon dioxide into organic products at two different stages, double carbon fixation. It's more efficient in water and energy use and tolerant in stress conditions related to climate change. Energy cane produces larger volumes of feedstocks such as lignocellulosic biomass, bagasse, and fermentable sugars, and has a higher annual production potential compared to other crops, including conventional sugarcane. For SAF production, cane bagasse is included in the positive list of materials classified as residue or waste by CORSIA, methodology for calculating actual life cycle emissions values. Its similarity to conventional sugarcane allows it to benefit from existing agricultural practice and expertise in Brazil's sugarcane sector, resulting in lower production costs, reducing investment, and fast agricultural implementation, less required crop area, and continuous annual availability. This leads to positive impacts on key factors such as availability all year long, homogeneity, cost, and sustainability. The sustainability is the main pillar for the project development. Concerning the social and economic benefits of energy cane, we may highlight that biomass-based advanced drop-in renewable fuels production projects stand out as catalysts for regional development to new and isolated agricultural frontiers, promoting the local community and economy in a profitable and sustainable manner. The three pillars, energy cane crop, geotechnology, and the BESS conversion technology, bring several benefits to the region where the project will be deployed, such as the introduction of agricultural technologies, proper selection of surrounding areas fit for production, and high-quality jobs creation. Brazil offers significant endophyclimatic conditions of tropical regions, with advantages for agriculture, including a favorable climate that allows multiple harvests per year, fertile soil, and vast freshwater water resources. The country's diverse climate supports a wide range of crops, and regular rainfall reduces the need for irrigation. The Brazilian Agricultural Research Corporation, Embrapa, and many other international biotech companies have been crucial in the development of agricultural technology in the country. Brazil has 66% of its lands preserved or protected by law, being a large and competitive agricultural, forestry, and agro-industrial producer. Brazil's expanding export infrastructure enhances its ability to compete globally, making it a strong foundation for agricultural development. It's estimated that logistics costs for exporting the final SAF would be 70% less than the cost of exporting ethanol for processing into jet fuel abroad. About the opportunity, the IATA forecasted potential for SAF production in the world by 2050 is 459 billion liters, 119 billion gallons, with Latin America region representing 12% of that volume. Assuming the same ratio of 12% by 2035-2036, the impact of Cenerbio SAF project in Latin America shall be more than 10% of total SAF produced in the region. IATA also envisions that between 140 and 185 billions shall be invested in Latin America in world-scale SAF plants by 2050. We propose BASF project as the best solution in face of current biofuels production crops and technologies are unsustainable and inefficient, leading to high land and lower reduction in carbon intensity. It's a disruptive concept of integrating biological, from first generation ethanol, and thermocatalytic technologies for production of SAF, ethanol, and bioenergy from energy cane non-food crop. Energy-based biofuels produced by BASF project shall have the following features. 1. Higher yield and lower production costs at more than 10 crops per planting. Self-sustained power and heat for industrial processing using existing lignocellulosic biomass. Integration of best available commercial energy crop with the highest yield conversion technologies. No competition with food production lands. The carbon reduction of BASF project is considerably higher compared to other ASTM-approved pathways, and due to the highest energy yield, the required land is much lower compared to other alternatives, such as HEFA and alcohol-to-jet from first-generation ethanol. The main lignocellulosic biomass conversion technologies were compared in terms of energy efficiency and capex. Hydropyrolysis technology stands out with the highest SAF yield per metric tons of biomass and the lower relative capex. This technology has already been submitted for approval in ASTM and it's currently in phase 1 OEM review. BASF project shall deliver the highest rate of land usage to produce about 300 million gallons of SAF, 1.14 billion liters per year. In the table, you can see the comparison for the same SAF equivalent production, showing the energy yield and land required for each alternative. BASF project outstands as the best alternative by far, showing less than half of planted area compared to the second best alternative, HEFA from canola oil, and impressive 24 times less area compared to HEFA from soybean oil. Cenerbio BASF project shows the best solution in terms of yield, economics, and capital de-risking, considering a 3 plants project separated into 3 phases, the first and second with production of ethanol, first generation ethanol, associated with SAF production using lignocellulosic biomass hydropyrolysis, and the third phase with the implementation of a large-scale SAF alcohol-to-jet production plant using ethanol from the 3 phases and additional SAF produced from hydropyrolysis plants. BASF integrated project is a disruptive concept of advanced and sustainable energy crop production integrating biochemical and biomass thermocatalytic technology for production of SAF, ethanol during ramp-up of plants 1 and 2, and bioenergy, heat and power for self-sustaining operation from energy cane, targeting SAF production mainly for exporting. The study showed a capex of approximately $3 billion, fully funded at 10% annual rate. The payback was less than 8 years and internal rate of return of 19%. The preliminary study also indicated 1. Fast implementation, higher yield, and lower production costs at more than 10 crops per planting, annual and all year long harvest. self-sustained power and heat for industrial processing using existing lignin cellulose biomass. 2. Integration of best available commercial energy crops supported by a dedicated breeding program with the highest yield conversion technologies. 3. No competition with food production lands. Integration with local communities by dedicated program of technology transfer and long-term purchase agreements with medium and small growers, generating permanent jobs. A further detailed feasibility study is crucial for investments in advanced renewable fuels projects, which will include the integrated production of SAF for exporting. Due to the complexity and early commercial stage of alcohol-to-jet and hydropyrolysis involved in the production of SAF from biomass, as well as how the regulatory and certification process, it's essential to present the fundamentals and specific features of these technologies to investors, including project location and local agriculture performance. Cenerbio proposal to deliver a pre-FEED project includes a cost of $600,000 for a thorough R&D study and a complete front-end engineering design study of the integrated project of 34 million, divided in 10 million, 12 million, and 12 million respectively according to the phase. Besides this, Cenerbio intends to be the partner to deploy and operate the project. To this end, we propose a free leverage share of 5%. Why now? Best SAF project is going to be aligned with the market trends for SAF demand and with the current needs and announced partnerships in the surging market. Number one, exponential global demand for sustainable aviation fuels. Number two, need of innovative technology, lower carbon intensity, such as energy cane and thermocatalytic technology. Number three, requires the best location for the project, as explained in the presentation, Brazil. And number four, strategic partnership has been established with investors and airlines. Please feel free to get in touch with Ivo Foto, Cenerbio CEO, for more details about the best SAF project.